Hello, everyone. I'm Del Pearson with Microwave Journal. I'd like to welcome you to the next installment of our technical education webinar series. This webinar is entitled Extend Battery Life in Multi-Radio Devices, the Antenna Strategies You Can't Ignore, and is sponsored by Ignion. Today's presentation will be given to us by two Ignion team members, Johan Peterson, Vice President of Product and Partners, and Sifiso Gambaya, Head of Customer Support. This webinar will provide some tried and tested strategies that help increase antenna efficiency and, in turn, extend the battery life of devices combining cellular, GNSS, and Wi-Fi connectivity. Attendees will also be given a preview of Oxion, an antenna integration platform that simplifies the design process and now provides automatic Gerber file reviews and recommendations. Before we jump in, let's go over a few logistics. If you'd like to download the presentation slides for reference, you'll find a copy in the handouts window to your right. We'll have time for questions after the presentation. To ask one, please type it into the Q&A window anytime. And the presentation is being recorded, so it will be available to watch again and recommend to your colleagues. Now let me introduce the real stars of the show, our speakers. With more than 15 years in the IoT industry, before Johan joined Ignion in Spain to lead the product and partner strategy, he's been in global product marketing and management roles of wireless SoCs at American companies Silicon Labs and Sigma Designs, as well as IoT and energy harvesting lead consulting clients on their new IoT designs at Force Technology and Delta in Denmark. Sifiso has more than 20 years of experience in the design, testing, and manufacturing of RF products for commercial and military applications. Some of the companies Sifiso has worked at include Ericsson, CommScope, and Corvo. Sifiso has had tremendous experience in antenna and RF development, having worked in South Africa, China, Taiwan, the UK, the US, Ireland, the Netherlands, and now Spain during his much-traveled professional career. And I will now hand it over to them to begin the real part of the show.
Thank you so much, Del. Thank you, everybody, for joining us today. It's a privilege to be able to present to you what we believe are very important considerations when it comes to wireless design. Sifiso, he will start with an overview of what multi-radio trends we see at Ignion, the different combinations of radios we see with our customers, and then dive into the key factors that affect the battery life, especially in these multi-radio devices, which is the antenna performance. If you have a poor antenna, you will have a poor battery life. So what is it that really affects there, and what are the key considerations that you need to take care of when designing your next device? And then following this, I will go into some of the challenges that you guys have told us about coming into this webinar. Thank you for that. And then we will talk about the different antenna types and categories there are for embedded antennas in the market, and a little bit deeper on our technology, the virtual antenna technology. And then, as Del said, we will take a peek into the Oxion platform that basically gives you superpowers when it comes to antenna design. And then we will round off with a hopefully extended Q&A session. We're really curious about your questions. So please type in as many questions as you have. We will try to cover as many as we can during this session. And then obviously afterwards, we will follow up on the ones that we are not able to cover. So please already now go in and type away, because basically what we are here for is to address the challenges that you are sitting with. So with that, let me hand it over to Sifiso.
Thanks, Johan. Hello, everybody. So to start off with, based on the data that we've gathered here at Ignion, most of the projects that we've seen in the last 3 years, approximately 53%, they require cellular and GNSS connectivity for devices used in industries such as asset tracking or automotive telematics. And you can see that illustration there on the left side. And you can see that half of those are essentially cellular and GNSS connectivity. And for the next slide, the key factors that affect the battery life of multi-radio devices, high power consumption in multi-radio devices obviously stems from several factors. primarily related to the continuous operation and simultaneous activity of multiple radio interfaces. For today, however, we'll focus on the antenna considerations, specifically those related to the antenna's efficiency. And if you go to the next slide, you can see for the antenna efficiency, the battery life is actually affected greatly by the design of the antenna. And in this case, what we've done is with our Nordic the Thingy 91X, we show here, where we have in this graph, two plots, one where we purposely detune the antenna, and, one at the top, the orange one, where the antenna is properly matched. And, we have the device transmitting continuously over a period of about 16 hours. And then later on, we check the battery drainage. And you can see succinctly, that when the antenna is poorly matched, obviously, you've got a high current consumption. And, your levels of battery are, they're drained quite significantly. So, that again highlights the importance in this case of proper antenna design and matching. And the next slide basically talks about antenna efficiency considerations, taking into account, your PCB sizes. We know nowadays that devices are getting smaller, and this poses a challenge because antenna efficiency, is obviously influenced by PCB dimensions. Smaller devices obviously mean limited space for the battery, and that means you need to have a more a device that can preserve battery life, and for that, it's very important to ensure that the antenna is designed in correctly as the PCB size gets smaller. Just to give you reference, when you decrease the length of your PCB by 10 millimeters, as an example, this represents a typical drop in efficiency of about 0.5 dB. And then the next slide, basically talks about, material influence on antenna efficiency. And here, you've got several, different media of transmission. You've got wood, you've got concrete, body, and metal. And, the materials in proximity of the antenna, definitely affect performance. So we recommend, for instance, low loss material for your housings and enclosures, the likes of polycarbonate plastics, PVC, those are standard in the industry. We have a design guideline on our website that can guide you through the best practices for embedding Ignion virtual antenna components into your design. Just to give you just an idea of the sort of losses that you can incur in these different types of materials, wood would typically represent about 4 dB insertion loss, in the propagation sense, and concrete, that's 18 dBs. The body is about 12 dBs, and solid metal, that's about 36 dBs. So it's very crucial because the material that you use will affect battery life in the long term because you're driving your antenna harder in order to basically realize performance. So the next slide basically talks about, again, antenna efficiency, but in the context of antenna placement. So the PCB that you see on your left-hand side, it's a typical, PCB from a customer design, as an example. We have 2 LTE antennas, and then we also have a GNSS antenna integrated all in the same PCB. So antenna to metal and to PCB component clearances are another important consideration to avoid near-field pattern losses and impedance mismatches. So the antenna placement, we recommend selecting an outer corner of the PCB on the longest side. The antenna component will also need a clearance area in the ground plane area and a keep out space of around 5 to 10 millimeters, free of any metallic elements in all directions. And then the next slide actually shows you the results from a simulation that we carried out on our Ignion platform. If you go to our website, you can actually avail yourself to this tool and you can do the very same design that I have illustrated here. So, it is desirable to have a return loss below 6 dB to ensure proper impedance matching of the antenna component and optimize total efficiency. So the red curve is essentially your total efficiency, and the green curve is your return loss. So using our Ignion antenna design integration platform for a multi-radio design, like I showed earlier just now, these are the typical efficiency values that you can get. And for this example, which shows antenna 1, this is an example for the primary LTE antenna. And we would say at around 40%, this should be enough to pass OTA carrier certification. And for the next slide, so this is also another plot for the secondary antenna. So the secondary LTE antenna is used for receive diversity. And efficiency is allowed to be lower, by the primary antenna by up to 3 or 4 dB. And this, consequentially actually helps improve antenna-to-antenna isolation. And then the next slide shows the return loss in the efficiency of the GNSS antenna. So an important thing to note here is that your typical isolation requirements for cellular and the GNSS radio is around 30 dB. So, we get about 15 dB of that isolation antenna to antenna, simply from our spacing between the cellular antenna and the GNSS antenna. And the rest of that isolation can be provided by the filter, a SAW filter at the front end of the antenna, and also at the radio. And then the next slide, shows us those isolation values that I just talked about. So, poor antenna isolation, particularly in mobile devices, can lead to battery drainage because it forces the network device to work harder to maintain that connection. When antennas not well isolated, they interfere with each other, resulting in a weaker signal and increasing power consumption. So here's a more detailed explanation of that graph that we're just talking about. So, poor isolation just means the device is constantly trying to find a strong signal, right? Which requires more power. And in this respect, there is increased power consumption. So when the signal is weak, your IoT device, uses more energy to transmit and receive data and to maintain the connection. And also another aspect that a lot of people don't really think about is, the device is continuously trying to search for a signal, all the time, and that this further, drains the battery. And then, of course, you've got your network connection issues because poor signals can also cause the device to drop calls or experience slow data rates, which can also contribute to battery drainage, whilst the device is constantly trying to reconnect and reestablish communication. And then, of course, you've got those, retransmissions, which essentially, draw a lot of current, and, that consequently drains your battery as well. So for the next slide, here, this is an often overlooked aspect of PCB design, the grounding. High levels of thermal noise and interference on the board can cause poor radiation efficiency and cause conductive sensitivity and conductive transmitted power of the module to vary wildly, and even for low power radios, leading to high current consumption. So in that respect, solid continuous ground planes at all layers with sufficient via stitching is the key to minimizing current loops and ensuring a low impedance return path for RF circuits by minimizing voltage drops and losses in the ground path, reducing overall power consumption of the circuit. And with that pretty much sums up my side of the presentation. And I would like to hand over the presentation to my colleague, Johan, who will go into more detail about our Ignion solution.
All right. Thank you for that, Sifisa. Let me start with summarizing some of the challenges that you guys have put in when you signed up. I know that we have more than 300 people who have signed up, and a lot of you have provided your challenges, so thank you for that. What we see is that in general, they relate to size, performance, and cost. Here you see number one being battery life optimization, space constraints, antenna matching, coexistence, multi-antenna placement, and such and so forth. And in general, what we see are the main challenges is to strike the right balance between ideally the small size, the high performance, and the low cost, obviously. Now, that is a difficult balance to strike. And we at Ignion are strictly focused on enabling you to striking the right balance for your product. Different products have different needs and requirements in terms of bands, performance, sizes, and we have a technology in the virtual antenna technology that enables you to really tailor that for your device. So if we look at the overall technologies that are available for integrated antennas, the virtual antenna technology is quite unique in the market for being non-resonant and frequency independent. I have our full portfolio right here. You see it a little bad, but anyway, you can see it on our website. There's 7 parts that can all be tuned to any band. If we start on this graph by looking at the lower left, here you see the custom antenna technologies, the 3D print, metal type of shapes. If you have $1 million budgets for your development and a big team and good time, then you can go ahead and build your own custom antenna. But a lot of companies don't have that available, hence they are opting for other technologies. So the next one up here is PCB trace. That is popular and can work well if you have enough board space, and for single band operation, fairly simple antenna, it can work fine. But as soon as you start needing a more compact design, or that you need multi-band, then you can run into challenges with getting enough performance out of a PCB trace type of a meander trace type of antenna. Then the one in the middle, the FPC antenna, that comes with a little cable and UFL. Those are popular if you forgot about the antenna to begin with, and you are left with little space on your board, a UFL connector, and then you're good to go. However, you can run into challenges when it comes to the mounting in production. It can be unreliable. You maybe need some hand mounting in there. It can be expensive. So overall, this is the reason why we are seeing in the market that many device makers opt for chip antennas, because they can deliver really good performance at a low cost level in a really compact form factor. In the market, there are 2 distinct categories of chip antennas: the resonant traditional chip antennas, and then the virtual antenna technology from Ignion being non-resonant. And the key difference here is that the resonant antennas are born with a certain set of frequencies in mind, and the virtual antenna technologies are not. So our technology gives you an extra degree of freedom of really optimizing both the performance and the cost point. So this is how we're simplifying the view of all of these technologies, because we know that it's a challenge to pick the right technology because there are so many things to choose from. And the way that we have gone about making it easy for you to choose is that because of our technology's predictability, we've been able to develop machine learning based models for all our 7 parts, actually 6 parts. And we have introduced this Oxion platform, which is our AI-powered antenna integration platform. You can already now, while being on this webinar, go in on oxion.ai and try it out while I show a few things here. But this is our way of making it easy for you to determine these important factors that Sifisa was highlighting in terms of ground plane size, antenna placement, clearance area, frequency bands, and really see what is influencing the antenna performance, because antenna design is a little bit of black magic. And if you don't have these fancy simulation tools or RF experts on the team, you can really benefit from using Oxion, because it basically gives you the power of an RF specialist without being one. So let's pull up the platform. So to make it short and sweet, I'm just doing this from a little video as I've taken from a screen dump, but this is the same view that you will see when you go and log in and create your first device. What I've done here is that I have created a smart device, and I would like to use cellular in the 824 to 960 and 1710 to 2690 bands. And I have a PCB that is 12 times 6 centimeters. Now, Oxion has then given me the recommendation of using the Ignion Run MX10 antenna. And then Oxion has also told me to, it has basically just given me this design out of the box, saying that you should place it here in the corner and with this clearance area that you see here on the screen. And then it gives me already the bare board efficiency that I can expect from this design. So in the graph, you see both the reflection coefficient and the antenna efficiency for the selected bands that I want on this antenna. Below, I also get the matching network topology that I can use to tune it to these specific frequencies. So basically, it is giving me the full antenna design, and I can, if I'm happy with it, I can go and now produce a prototype and get going with this design. Now, this is approaching 80% efficiency and 60% in the lower bands. Maybe that is even more than I need. So a really cool feature that we have in here is our AI Design Explorer, to then enables me to change things and see how the efficiency will respond. So in the AI Design Explorer, if I click there, then I can basically see that if I change the size of the PCB or the area of the clearance, I can see the resulting efficiency immediately. And this is super cool. This enables me to do many iterations in the digital space before doing any prototypes. So it basically saves you a lot of prototyping work because you can build 10, 20 different digital prototypes here before selecting the exact setup that you would like. And I've done it for simplicity just for one antenna here. Oxion actually enables you to do this with up to 5 antennas on the same board. And as Sofiso showed you in his slides, it will also tell you about the isolation between these different radios. So you can assess whether it actually makes sense or not to continue with this design idea before even building anything. Then when you're happy with it, you can export the design file into your own Gerber design tool, and then work and populate the board with the wireless module and sensors and connectors and whatever else you need on the board. And then you can re-upload it to Oxion for it to verify that you have followed the design guides correctly in terms of feeding line, pad dimensions, and so. It's an automatic review that's done in 20 minutes. And then once Oxion tells you, yes, you're good to go, then you can go and produce your prototype, and you should be good on your way with a high-performing prototype. If you have any questions during this journey, we of course have, as everybody else, we have built an AI assistant. Ignion's AI assistant is called Max, and you find Max down here in the right corner, the little circle here with the little stars. There you can ask any question about antennas, and Max will answer based on all our documentation. So you no longer need to go and read any Ignion application note. You just ask Max and he will tell you. He can even calculate things for you. And so like it's really, really helpful. And if you need to speak to a person, Max can also introduce you to one of the Ignion team members that sits ready to address whatever questions you might have. All right, let's jump back to the slides. So Oxion.ai, please go in and check it out. It's free to use. We really want to empower everybody to do great antenna design with this tool. So to summarize in an obvious way, if you optimize your antenna integration, if you optimize and match the antenna impedance correctly, you will ensure long battery life, reliable communications, and long range in your device. If you don't, then you will look into reduced battery life, poor communication, and even in some extreme cases, if there is a lot of reflected power coming back from the antenna because it is poorly designed and poorly matched, you might even damage the chipset. Obviously, we are here to help you and make sure that that is not happening. And a good example of a really successful multi-radio design is this one we recently did together with Nordic Semiconductor. This is the Thingy 91X platform. It is a 5x5 centimeter board that is based on the NRF 9151 cellular module. And you can see here the Ignion Trio M extent that is doing the cellular part, so LTE-M, narrowband IoT, actually also DECT NR+, and now also satellite NTN. And then next to that, we have the Ignion Duo M extent for GNSS, and then the Nano M extent here in the middle of the board that is covering both BLE and Wi-Fi dual band. Now, that is a lot of wireless on a tiny, tiny board, so you would expect lower performance. But as you can see on the graph to the right, we have really been able to maximize it and really squeeze everything out that was possible. And you can see the different bands here, and you across the cellular lower bands, the GNSS, the higher band cellular, and the dual band Wi-Fi. That is really impressive performance that we're getting here. But it's because that we are following all of those things that Sefisa was highlighting in terms of clearance, ground planes, the isolation between the parts. The cool thing is when you use a single type of antenna technology on the board, we see customers mixing and matching sometimes. When you only use one antenna technology, you can really control it well if you're using our technology, at least to make sure that they don't interfere with one another, and we maximize the isolation and getting the maximum performance out of this platform. So this is a really cool example of a tiny device that delivers high antenna efficiency and hence high long battery life. Okay, so with that, I will hand it over to Del, who will take us through the Q&A.
Thank you, Johan and Sefisa. That was a great presentation. Lots of information for the viewers. I'm sure we have a lot of questions to address. If you've not done so already, please submit any questions to the Q&A tab and we'll answer as many as time allows. In the meantime, let's start with this one. How do users select or design antennas for BLE short range, Wi-Fi, and broad antennas?
Sefisa, you want to take that one?
Yep, I'm going to take that one. Yeah, so us at Ignion, basically we have a highly streamed product portfolio of 7 antenna boosters. These are 7 products, that can be easily tuned to cover all these requirements. These products are available on our website and can be adapted to your requirements. We also have our Ignion antenna integration platform that can guide you step by step for the integration of these antennas. So all these different applications can be covered from our antenna products, essentially.
And Oxion will basically tell you, if you requested an Oxion, then we'll tell you which one of them.
Thank you. We've a new one in. When is it a good strategy to decrease the maximum transmission power configuration to try to extend battery life?
Yeah, so I can answer that one. So it literally depends on the type of certification that you have, because if you're and the radio class that you're using, right? So if it's a class 2 radio, for instance, the transmit power requirements might be lower than a class 3. And, in that regard, it dictates that, you can actually use, lower transmit powers, because it's really about the certification requirements and the TRP requirements for that particular, radio class, essentially. So that's driven more from a radio, design perspective.
Great, thank you. Another question, how can we optimize performance while meeting regulatory gain limits?
Yeah, I can take that one too. So for FCC Part 15 rules, such as for Wi-Fi and Bluetooth, essentially all we need to do as Ignion is just mesh the antenna so that we can stay within the peak gain limits for that modular certification, for instance. And in that case, you can either get a permissive change class 1, where there is no need to refile with the FCC, if the antenna is the same gain and type as the original antenna used for the original certification, or else you have to go for a permissive change class 2, and then you might have to refile again with the FCC. But the point is, we're able to actually, mesh the antenna to adhere to those requirements with peak gain, whilst maintaining performance, essentially.
Awesome, thank you. We have a question in about how can a user design an antenna for underwater use in the Wi-Fi range?
So typically, propagation says that, whether it's Wi-Fi or LTE or whatever the case is, there's great attenuation in water. You typically would not be designing an antenna underwater, but we have seen systems where you can tether, let's say, for instance, the device to a wire, transmission wire or whatever it is that's sending the signal down to your device underwater. But to have, propagation down into water, that's not going to work very well.
Thank you. And next up, how does Ignion work with a small ground plane or retune small PCBs electrically?
Yeah, so this is a very good question. So, our booster non-resonant virtual antenna technology is actually ideal for these small PCBs, since it does not depend on a quarter wavelength for resonance, right? So, these antenna structures that we have are non-resonant, and all you need is the matching network to boost efficiency on the ground plane. So we don't necessarily rely on a quarter wavelength for operation.
Thank you. Let's see what the next question is. Just a moment. How do we use Trio M Extend TM antenna with an antenna tuner cellular modem? They give an example, but I'm wondering if you could answer that more broadly.
Sure. Should I take this one, Johan?
Sure, I can also. So I see that it's related to a Telit or a Telit module. We work closely with Telit. We see a lot of our clients using the combination of Trio and our Trio antenna and the likes of this cellular modem. It can be integrated using a passive matching network, as we saw in the Oxion platform, or it can also be integrated using an active network that includes a switch, like that was seen on the Thingy:91X example. So both of those options are available depending on the board size and the performance requirements. But those go very well hand in hand, the Trio and that module that you're mentioning.
Great, thank you. We have another question for a pentaband. Normally chip antennas have different pads to add passives or stubs for specific band tuning. How is this done with Ignion?
I will let Sifiso take that one.
Yeah, sure. So, for us, essentially, as I mentioned earlier, our antennas are non-resonant. And in that case, what we're actually doing is exciting modes on the ground plane. So the actual antenna element itself, is not a resonant structure, but it's a booster which enables, the correct modes, radiation modes on the ground plane, in order for us to be able to excite any bands, whether it's low band, mid band, mid to high band. All we need essentially is just a matching network to literally shape those particular bands that we require at a time.
Great, thank you. Another question is in, can you describe the body clearance in brief? For example, if it's a wearable like a wristwatch, just give some more details on that.
Yeah, sure. So, for a wearable, of course, it's right up next to the body. And sometimes the only clearance that you have is essentially your housing, right? So at the end of the day, efficiencies are usually quite low, but, those applications are, usually Bluetooth or BLE. And, with efficiencies of around 10%, you still get sufficient coverage. And we've never really had any problems, regarding performance with those antennas. So really, it just really depends on how much contact you have with the skin. And that depends on the housing structure.
Awesome, thank you. How do you take external modules with existing antennas into account when designing your circuit?
Right. So here we're talking about existing modules with external antennas. Well, it all depends, right? Because at the end of the day, it doesn't really matter, what module it is. For us, our antennas are, can work with any radio module. All we need to do again is just designing in our antennas on your PCB. And, we incorporate the right matching network and topology, and, we're able to radiate efficiently.
I think if I can add there, so I think the question might also, if you have a main board, then you have a module that has an antenna on it. For example, we have a module with Isurio for BLE that is a little PCB module with a Ignion chip antenna that you can then mount on a main board for your particular application. What we do in those types of configurations is that the module is designed for the use of being embedded in a main board and being optimized for that, so that the main board effect is already taken into consideration in the actual antenna design, so that it's robust to be integrated in many different form factors. And we're actually seeing more and more of these small modules going from PCB trays to using a chip antenna architecture, because we've seen that, for example, in BLE, we can deliver more than 3 dB. We can deliver double the antenna efficiency in those modules compared to the PCB trays variants.
Great, thank you. Another question is in, is the procedure for the chip antennas the same as the procedure for the matching circuit?
So the procedure for matching the Ignion antennas with a matching network is similar as to other resonant chip antennas, but because we have that extra flexibility, you have extra flexibility in tuning, and Oxion tells you exactly how you should tune it, whereas with others you don't have that helper in Oxion next to you. So in that sense, it's a little different, but it's the same principles with the inductors and capacitors to tune it to the specific bands. Safiso, I see you off.
I'm right here.
There we go.
All right, another question. Can we use this antenna for RFID as energy harvesting technology?
Yeah, sure. Of course you can. Whatever frequency band you're using for your RFID, whether it's 400 megahertz band or the 868 band, we're able to cover those. Our antennas are broadband, they're wideband, able to cover 400 megahertz, all the way to 11 gigahertz as an example. So yes, you can. The answer is you can.
Awesome, thank you. And another question in, for curved wearables with rigid PCBs and chip antennas, do you have any recommendations on how ground planes could be extended to improve efficiency?
Right. So, typically for those sort of like flexes, that are wearables, like if you look at a watch, for instance, a strap, can have, a flexible PCB embedded in there. And that in itself can be an extended ground plane and, boost performance as an example. Outside of the main ground plane, that could be in the ring of the watch. Those are other techniques that are used to extend ground plane.
Thank you. We have one on training. Is there any offline or in-person course for testing and tuning antennas in the laboratory?
So we have the Virtual Antenna Academy. That is a good place to start for the basics, and then we do work with our customers on specific training needed. So depending on what region you're based in, like please shoot us a note, and we can get you in touch with the regional technical team that can give you the training. Basically, our technology, we want everybody to be able to tune it themselves, not needing Cefiso and the team just for the complex problems. So definitely, if you have any specific needs here, let us know, and we'll guide you. And then also use Max in Oxion. He will also be able to help you.
Awesome. I wish I had a Max in everyday life. Another question is in, what are some efficient solutions for NB-IoT and LTE-M impedance matching?
Right. So, again, for, NB-IoT, we have our, the 7 antenna booster products that we offer. And, these are like low power sort of like applications, but, the requirements are exactly the same as far as, carrier certification and so forth. So what we do is, we match your antenna, in your product, using, again, as Johan pointed out earlier, using our software tool, Ignion, and it gives you a guidance there to the sort of matching network topology that you need for, best performance, nothing outside the realm of, proper antenna design.
Great, thank you.
I see, just connected to the question we were just talking about with the training and the matching, that we have one that's called on the measuring, if it's VNAs you do to do the tuning, and the answer is yes, you use a VNA to do the antenna tuning, and basically measuring that the reflection of the antenna is on the right frequencies that you want them to. And then by adjusting the passive matching network components, you can see the resulting change using a VNA. So it's fairly simple, and something that a hardware engineer in general, you don't need to be an RF expert to do this. You can do that with a typical VNA. Yes.
Great, thank you for adding that additional detail. Is the radiation pattern affected by the matching network?
Yeah, so I can answer that one. The answer is yes. So, if you have an optimal matching, at the antenna, then, you're radiating efficiently. And, efficiency is just, really a measure of the, the radiation characteristic, of the antenna. So, in that regard, better matching, a better radiation pattern.
And just to add to that, Ignion antennas are omnidirectional. So all of our parts radiate in 360 degrees, which makes them really ideal for devices. You don't need to worry about any type of mounting direction because they basically radiate omnidirectionally.
That is correct.
Thank you. Quickly back to the VNAs. Do you have a recommended best practice on how to connect the VNA without influencing the antenna pattern or path?
Right. So yeah, this is a very good question. So the whole idea is, you do have a measurement cable, which is typically some sort of like semi-rigid coax. You want to make sure that that coax is properly grounded, and, soldered down on the PCB, routing away from the antenna element itself. And, in that way, there's no influence, on the radiation characteristics, and that cable is not radiating. So it does not affect your actual antenna measurement. So those are some of the things that we do on the bench when we're matching antennas using a VNA.
Awesome. Is there a single antenna that supports LoRa, GPS, and BLE?
Yeah, the answer is yes. We have several parts, that can do that. And, you are actually able to have multiple ports that you can, activate on that antenna. And, you can have all those concurrently if that is the desire. And you're able to go to those separate respective radios without the need of 3 separate parts, as an example. So we do have that. And if you go to our website, you're going to see our whole product portfolio with some of those descriptions.
Yeah, the Trio MX10, the 310 will be good for that, for example.
Yeah, the Trio would be a perfect example for that.
I also see there's another question similar to if we have antennas for DECT, NR Plus, and ultra wideband. We do. Those frequencies fall very much into our operating range. DECT NR Plus is typically in the 1.9 gigahertz region. This is where we see our dual antenna being used a lot. And also in ultra wideband, we have our duo and also our nano that operates both in the ultra wideband low frequency range in the 3 to 5 gigahertz region, and also in the 6 to 8 gigahertz region with the same parts. So for DECT and ultra wideband, look at you can start with the dual, one, or nano antennas. They can all operate there, and it's basically a question of whether you want performance or cost. Some of them are cheaper than others, and some of them can get a little bit more performance. And Oxion will guide you in what is best for you.
Great. How does multi-feed work to eliminate the RF switch?
Right. That's a very good question. So if you have a multi-feed antenna, you've got 3 separate paths to your respective, radio modules. So in that case, if you've got a radio module with 3 independent ports, you can just connect those ports, directly without the need of, let's say, a single antenna. That needs to be switched between 3 separate radios, as an example. So you have a one-size-fits-all, which is able to actually, cater for that minus the switch.
Awesome. And I think time-wise, that wraps up our Q&A. We do record all questions, so if we were not able to answer yours, someone from the Ignion team will reach out separately and answer those for you. So thank you, everyone, for submitting. We look forward to wrapping up all the answers for that. I'm going to pass the mic back to Johan and Safiso to get into a quick recap of today's session.
Yeah, thank you, Del, and thank you for all your good questions. As noted, Oxion.ai is your resource for all these challenges and questions. So please go in there and continue the discussion either with us or with Max. There was a question also if it was it cost anything to use Oxion. It does not. It is free to use. So please go in there and enjoy that. To recap, we are Ignion. We are headquartered in Barcelona, in Spain, but we are a global company. We have offices both in the US and in China as well. We serve a lot of clients across many different sectors with wireless solutions. We are in more than 60 million devices out there. You will see us at the little red part shining on the board. And we've been at it for more than 20 years. You've known the name Ignion in other constellations as well, but our whole team has been at it for this many years, and we are all about optimizing the RF performance at a low cost for your devices. Now, the technology that we bring to you is the virtual antenna technology. It is a little different than the others out there, as we've been covering today. And just to recap, it consists of the antenna booster element, the little red chip that you tune with the matching network, and then it ignites the ground plane. That's also why we call it Ignion. And the combination of those three elements is your antenna solution that brings you all those benefits that we've been covering today. Now, the last slide, a few links. You can go, and if you feel like a little old school actual reading technical documentation, we invite you to do that. We have a lot of it. But as I've been saying, Max is your new friend. So go to oxion.ai and get familiar with him there. And then for the ones who would like to show their boss a certificate of having taken the Virtual Antenna Academy course, our CTO is also a professor in the Barcelona University in antennas, and he, together with the university, we have developed a course where when you finish, you get a fancy certificate. So please go to the link below here to read more about and sign up for that too. That is also for free. And then I think I will say thank you for participating. Thank you to Cefiso, and hand it back over to Del.
Awesome, thank you. Yep, in the interest of time, I'm going to close the webinar here. I'd like to thank Johan and Cefiso again for the presentation and for answering all the great questions. And I'd also like to thank Ignion for sponsoring this webinar. As I mentioned right at the beginning, the webinar has been recorded and will be available to watch later today. You'll find it in the events section of the Microwave Journal website under the archived webinars and events tab. So please feel free to watch it again and share it with any of your colleagues who may be interested. And remember, if you're not already a subscriber to Microwave Journal, you can sign up on our website. The subscription is free to members of the industry. Now, let me close by saying thank you to everyone for joining us today. Please keep an eye out for upcoming webinars and panel sessions, and I hope to see you at an industry event soon.
Thanks, Madeline.
Thank you all.